this is Britt Caswell with another example video. In today's video, I'm covering example 4 from section 7-1 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to add polynomials. So when Savvas starts this problem, what they want us to do is they want us to kind of compare adding polynomials to adding whole numbers. Okay, so I'm going to start by doing an example here, which is, kind of elementary, right? We do that in the lower elementary grades, and then I'm going to do it again, but in terms of polynomials. Okay, and so I'm hoping that by doing this side by side, we could kind of get that comparison. Now, the biggest thing here is that you guys remember that polynomials do not have us carry tens. All right, so you will not encounter a situation where you have to carry a 1 anywhere, which makes adding polynomials a little nicer than adding whole numbers. Alrighty, so let's do our little easy problem, right? So when we go to add these, what we do is we always add together the columns of, like digits, I should say. So for example, the 3 and the 5 here are both in the ones place, and so those are the ones that get combined together. The 2 and the 0 here in this place, those are in the tens place, and so we would combine those together. We wouldn't combine a 10 and a 1, right? We wouldn't add those together. That doesn't make sense. And in our hundreds place, we have a 4 and a 1, which makes 5. So it's really important when we're adding whole numbers, right, that we add together digits that are in the same position, right, in the ones, the tens, or the hundreds. So when we add together polynomials, it works the same way. Now, one thing worth noting here is that with these polynomials, you could kind of see there's like a big gap here, right? There's no x term. So if it helps you to visualize it, you could put a plus 0x here. Because 0 times x is 0, you're not actually really doing anything but putting a placeholder. And so sometimes that makes it easier for people to see when they're doing this. This is called the stacking method. See, because we stacked one polynomial on top of the other. And so now we could just go through and we can add them. And what's nice about polynomials is because we don't carry, it doesn't matter the order you add them with. I like to go from left to right. So 1x squared, which, by the way, you don't always have to have the 1. It could just say x squared. Plus 4x squared is 5x squared. 2x plus 0x is 2x. And 3 and 5 makes 8. So do you see how adding these polynomials got me the same thing? Alright, so now let's try part B. So with part B, what I'm going to do is continue with that stacking method, because I have a hard time seeing it when it's stretched out like this. So what I'm doing here is I'm just writing down that first polynomial, and then I'm going to write this second polynomial underneath it. Now it's very important when I go to do that you make sure to have like terms underneath each other. So this 3x squared has to go into the x squared column. It can't go under the linear one. And the 6 has to go where the constants go. I can't put it under the x. So make sure when you're doing the stacking method that you have the same variable to the same exponent stacked on top of each other. And then when I go to add, I'm just going to add down. So 4x squared and 3x squared makes 7x squared. The 2x plus nothing is 2x. And negative 3 plus 6 is 3. Now you can add by just collecting. Okay, I'm going to show you that with part A, and I'll stack with part B. I'm just not as big of a fan of it. Alright, so with this what I would do is I would just essentially be collecting my like terms, okay? So I only have a single x squared term, So I'm just going to write out that 3x squared, not cubed. And then I'm going to look for my linear terms. So for my linear terms, I have 2x and a negative 1x. So together that makes 1x. And then I only have one constant, which is a 9. So on the more basic ones like this, you can kind of just collect them easily. But once you get more and more terms, it gets a little harder, okay? And that's where I think stacking goes into place. So here I'm just going to stack these ones. So I have negative 2x squared plus 5x minus 7. And underneath it, I'm going to put my 3x and my 7. So notice this 3x doesn't have a square, so it's going to come over here, like that. All right, now to add these together. So negative 2x squared plus nothing is negative 2x squared. 5x plus 3x is 8x. And negative 7 plus 7, they cancel each other out, because when you subtract and add the same amount, they are inverse operations. And there you have it. There's our final solution. Alrighty, so that is how we add polynomials. Until next time.